Welcome to all. COVID-19 has resulted in schools shut all over the world last year. As a result, education has moved online classes. In our YouTube channel, we are focusing the reading the English textbooks in Tamil Nadu matriculation syllabus so that students can review the subjects when they find time. We are recommending our kids and teens should learn the education from their teachers, and in-person education is extremely good for all age students since teachers know students' needs. Students, today we are going to read the 10th Standard Science book, Unit 1 Laws of Motion, page number 1 to 4. We are going to cover introductions, 1.1 Force and Motion, 1.2 Inertia, Types of Inertia, and Examples of Inertia. 1.3 Linear Momentum, and 1.4 Newton's Laws of Motion. Newton's Laws. 1.4.1 Newton's First Law. 1.4.2 Force. 1.4.3 Types of Forces. A. Like parallel forces. B. Unlike parallel forces. 1.4.4 Resultant force. 1.4.5 Rotating effective force. Laws of motion. Learning objectives. At the end of this lesson, students will be able to understand the concepts of force and motion. Explain inertia and its types. State the 3 laws of Newton. Apply Newtonian concept of force and motion. Define force, momentum and impulse. Distinguish between mass and weight. Analyze weightlessness and the principle of conservation momentum. Explain the law of gravitation and its applications. Understand the variations in g due to height and depth. Solve numerical problems related to force and motion up or slows down or changes its direction. What speeds up or slows down the body? What changes the direction of motion? Introduction. Human beings are so curious about things around them. Things around us are related to one another. Some bodies are at rest and some are in motion. Rest and motion are interrelated terms. In the previous classes you have learnt about various types of motion such as linear motion, circular motion, oscillatory motion, and so on. So far, you have discussed the motion of bodies in terms of their displacement, velocity, and acceleration. In this unit, let us investigate the cause of motion. When a body is at rest, starts moving, a question that arises in our mind is what causes the body to move. Similarly, when a moving object comes to rest, you would like to know what brings it to rest. If a moving object speeds up or slows down or changes its direction. What speeds up or slows down the body? What changes the direction of motion? One answer for all the above questions is force. In a common man's understanding of motion, a body needs a push or pull to move, or bring to rest or change its velocity. Hence, this push or pull is called as force. Let us define force in a more scientific manner, using the 3 laws proposed by Sir Isaac Newton. These laws help you to understand the motion of a body, and also to predict the future course of its motion, if you know the forces acting on it. Before Newton formulated his 3 laws of motion, a different perception about the force and motion of bodies prevailed. Let us first look at these ideas, and then eventually learn about Newton's laws in this unit. Mechanics. Mechanics is the branch of physics that deals with the effect of force on bodies. It is divided into 2 branches, namely, statics and dynamics. The inherent property of a body to resist any change in its state of rest or the state of uniform motion, unless it is influenced upon by an external unbalanced force, is known as inertia. Statics. It deals with the bodies, which are at rest under the action of forces. Dynamics. It is the study of moving bodies under the action of forces. Dynamics is further divided as follows. Kinematics. It deals with the motion of bodies without considering the cause of motion. Kinetics. It deals with the motion of bodies considering the cause of motion. Force and motion. According to Aristotle, a Greek philosopher and scientist, the natural state of earthly bodies is rest. He stated that a moving body naturally comes to rest without any external influence of the force. Such motions are termed as natural motion, force independent. He also proposed that a force, a push or a pull, is needed to make the bodies to move from their natural state, rest, and behave contrary to their own natural state, called as violent motion, force-dependent. Further, he said, when two different mass bodies are dropped from a height, the heavier body falls faster than the lighter one. Galileo proposed the following concepts about force, motion, and inertia of bodies. The natural state of all earthly bodies is either the state of rest or the state of uniform motion. 2. A body in motion will continue to be in the same state of motion as long as no external force is applied. 3. When a force is applied on bodies, they resist any change in their state. This property of bodies is called inertia. 4. When dropped from a height in vacuum, bodies of different size, shape, and mass fall at the same rate and reach the ground at the same time. 1.2 Inertia. While you are traveling in a bus or in a car, when a sudden brake is applied, the upper part of your body leans in the forward direction. Similarly, when the vehicle suddenly is moved forward from rest, you lean backward. This is due to any body would like to continue to be in its state of rest or the state of motion. This is known as inertia. In activity described above, the inertia of the coin keeps it in the state of rest when the cardboard moves. Then, when the cardboard has moved, the coin falls into the tumbler due to gravity. This happened due to inertia of rest. Linear momentum. The impact of a force is more if the velocity and the mass of the body is more. To quantify the impact of a force exactly, a new physical quantity known as linear momentum is defined. The linear momentum measures the impact of a force on a body. The product of mass and velocity of a moving body gives the magnitude of linear momentum. It acts in the direction of the velocity of the object. Linear momentum is a vector quantity. Linear momentum equals mass times velocity. P equals mv. It helps to measure the magnitude of a force. Unit of momentum in SI system is kgms-1, and in CGS system its unit is gcms-1. Newton's first law. This law states that every body continues to be in its state of rest, or the state of uniform motion, along a straight line, unless it is acted upon by some external force. It gives the definition of force as well as inertia. Force. Force is an external effort in the form of push or pull, which 1. Produces or tries to produce the motion of a static body. 2. Stops or tries to stop a moving body. 3. Changes or tries to change the direction of motion of a moving body. Force has both magnitude and direction, so it is a vector quantity. Activity 1. Take a glass tumbler and place a small cardboard on it as shown in the figure. Now, keep a coin at the center of the cardboard. Then, flick the cardboard quickly. What do you observe? The cardboard falls off the ground, and the coin falls into the glass tumbler. Types of inertia. A. Inertia of rest. The resistance of a body to change its state of rest is called inertia of rest. B. Inertia of motion. The resistance of a body to change its state of motion is called inertia of motion. C. Inertia of direction. The resistance of a body to change its direction of motion is called inertia of direction. Examples of inertia. An athlete runs some distance before jumping, because this will help him jump longer and higher. Inertia of motion. When you make a sharp turn while driving a car, you tend to lean sideways, inertia of direction. When you vigorously shake the branches of a tree, some of the leaves and fruits are detached, and they fall down, inertia of rest. Types of forces. Based on the direction in which the forces act, they can be classified into two types as A. Like parallel forces and B. Unlike parallel forces. A. Like parallel forces. Two or more forces of equal or unequal magnitude acting along the same direction, parallel to each other, are called like parallel forces. B. Unlike parallel forces. If two or more equal forces or unequal forces act along opposite directions parallel to each other, then they are called unlike parallel forces. Action of forces are given in Table 1.1. Students, refer your book and view the table or picture carefully, and ask your school teacher for clarifications. Resultant force. If the resultant force of all the forces acting on a body is equal to 0, then the body will be in equilibrium. Such forces are called balanced forces. If the resultant force is not equal to 0, then it causes the motion of the body due to unbalanced forces. Examples: drawing water from a well, force applied with a crowbar, forces on a weight balance, etc. A system can be brought to equilibrium by applying another force, which is equal to the resultant force in magnitude, but opposite in direction. Such force is called as equilibrant. Rotating effect of force. Have you observed the position of the handle in a door? It is always placed at the edge of door and not at some other place. Why? Have you tried to push a door by placing your hand closer to the hinges or the fixed edge? What do you observe? The door can be easily opened or closed when you apply the force at a point far away from the fixed edge. In this case, the effect of the force you apply is to turn the door about the fixed edge. This turning effect of the applied force is more when the distance between the fixed edge and the point of application of force is more. Axis of rotation. The axis of the fixed edge about which the door is rotated is called as the axis of rotation. Fix one end of a rod to the floor/wall and apply a force at the other end tangentially. The rod will be turned about the fixed point is called as point of rotation. Thank you for all. In our next video, we will post the 10th Standard Science next unit.